Okay, can everyone hear me okay? Okay, so welcome back. I'm gonna address a couple of items in kind of the administrativia. With the kind of the end of the first week, we sent an email kind of noticing you that we have uploaded the videos for the first week, so you can now find them online. They have all the screen recordings for the things that we were doing, so you can go back to them, look if you were kind of confused about we did something quick. And again, feel free to ask us any questions if anything in the lecture notes is not clear. We also kind of send you surveys, so you can give us feedback about what was not clear, what items you will want to kind of a more thorough explanations, or just any other item. If you're kind of finding the exercises too hard, too easy, go into that URL and we'll kind of really appreciate kind of getting that feedback, because that will kind of make the course better for the remaining lectures and for future iterations of the course. With that out of the way, and we're going to try to upload the videos in a more kind of timely manner. Like we don't want to kind of wait until the end of the week for that, so keep tuned for that. That out of the way, now this lecture is called Command Line Environment, and we're going to cover a few different topics. So the main topics we're gonna cover, so you can keep track, it's probably better here, keep track of what I'm talking. The first is gonna be job control. The second one is gonna be terminal multiplexers. Then I'm gonna explain what dot files are and how to configure your cell. And lastly, how to efficiently work with remote machines. So if things are not fully clear, kind of keep the structure. They all kind of interact in some way of how you use your terminal, but they are somewhat separate topics, so keep that in mind. So let's go with job control. So far we have been using the cell in a very kind of mono-command way. Like you execute a command, and then the command executes, and then you get some output, and that's all about what you can do. And if you want to run several things, it's not clear how will you do it. Or if you want to stop the execution of a program, it's again like, how do I know how to stop a program? Let's showcase this with a command called sleep. Sleep is a command that takes an argument, and that argument is going to be an integer number, and it will sleep. It will just kind of be there on the background for that many seconds. So if we do something like sleep 20, this process is going to be sleeping for 20 seconds. But we don't want to wait 20 seconds for the command to complete. So what we can do is type Control-C. By typing Control-C, we can see that the terminal kind of let us know in this one of the syntax that we cover in the editor's last Beam lecture, that we type Control-C and it stopped the execution of the process. What is actually going on here is that this is using a Unix communication mechanism called signals. When we type Control-C, what the terminal did for us, what the cell did for us, is send a signal called SIGINT, that stands for kind of signal interrupt, that tells the program to stop itself. And there are many, many, many signals of this kind. And if you do man signal and just go down a little bit, here you have a list of them. They all have like number identifiers. They have kind of a sort name, and you can find a description. So for example, the one I have described is here. Number 2, SIGINT. This is the signal that a terminal will send to a program when it wants to interrupt its execution. A few more to kind of be familiar with is SIGQUIT. This is, again, if you are from a terminal and you want to quit the execution of a program, which for most programs will do the same thing, but we're going to showcase now a program which will be different. This is the signal that will be sent. It can be confusing sometimes kind of looking at these signals. For example, the SIG term is, for most cases, equivalent to SIGINT and SIGQUIT, but just is when it's not sent through a terminal. A few more that we are gonna cover is SIGAP, is when there's like a hang-up in the terminal. So for example, when you're in your terminal, if you close your terminal and there are still things running in the terminal, that's the signal that the program is gonna send to all the processes to tell it that they should close. Like there was a hang-up in the command line communication and they should close up. Signals can do more things than just like stopping, like interrupting programs and like asking them to finish. You can, for example, use the SIG stop to pause the execution of a program. And then you can use the SIG cont for continue to continue the execution of that program at a point later in time. Since all of these might be slightly too abstract, let's see a few examples. First, let's showcase Python program. I'm gonna kind of very quickly go through the program. This is a Python program, and unlike most Python programs, it's importing this signal library, and it's defining this handler here. And this handler is writing, oh, I got a second, but I'm not gonna stop here. And after that, we kind of tell Python in a way that we want this program when it gets a second to stop. And the rest of the program is a very silly program that is just gonna be printing numbers. So let's see this in action. We do Python second, and it's counting. We try doing Control-C, this sends a second, but the program didn't actually stop. This is because we had a way in the program of dealing with this exception, and we didn't want to kind of exit. If we send a SIGQuit, which is done through control backlash here, we can see that since the program doesn't have a way of dealing with SIGQuit, it does the default operation, which is kind of terminate the program. And like you could use this, for example, if someone Control-C's your program, and your program is supposed to do something like you maybe want to save the intermediate state of your program to a file so you can recover it from later. This is how you could write like a handler like this.
So what did you type in order to get it?
Can you repeat the question, sir?
What did you type right now when it stopped?
So
Anything?
what I type is I type Control-C to try to stop it, but it didn't because SIGINT is captured by the program. And then I type control backlash, which sends a SIGQuit, which is like a different signal. And the signal is not captured by the program. And it's also worth mentioning that there's a couple of signals that cannot be captured by software. Like there's a couple of signals. These are SIGKILL, and that cannot be captured. Like that one will like terminate the execution of the process no matter what. And it can be sometimes harmful. You don't want to be using by default because this can leave, for example, orphan children processes. Like if a process has other like small children processes that it started and you SIGKILL it, all of those will keep running in there, but they won't have a parent, and you might have really weird behavior going on. Go ahead.
What signal is given to the program if we, let's say, log off?
If you log off, that will be, so for example, if you're in a SSH connection and you close the connection, that is the hang-up signals, like the SIG HUB, which I'm going to cover in examples, or at least what will be sent up. And you could write, for example, if you want the process to keep working even if you close that, you can write a wrapper around that to ignore that signal. Let's display what we could do with the stop and continue. So for example, we can start a really long process, sleep 1,000, it's going to take forever. We can control Z, and if we do control Z, we can see that the terminal is saying, oh, it's suspended. And what this actually meant is that this process was sent a SIG stop signal, and now is still there. You could continue its execution, but right now it's completely stopped and it's in the background. And we can launch a different program. When we try to run this program, please notice that I have included an ampersand at the end. This tells Bash that I want this program to start running in the background. This is kind of related to all these concepts of running programs in the cell, but backgrounded. And what is going to happen is the program is going to start, but it's not going to take over my prompt. Like if I just run this command without this, I could not do anything. Like I will not have access to the prompt until the command either finished or I ended it abruptly. But if I do this, it's saying, oh, like there's a new process, which is this. This is the process identifier number, and we can ignore this for now. And if I type the command jobs, I get the output that I have a suspended job that is the sleep 1000 job. And then I have another running job, which is this nohab sleep 2000. Say I want to continue the first job. Like the first job is suspended, but it's not executing anymore. I can continue that doing bg %1. That percentage is referring to the fact that I want to refer to this specific process. And now if I do that, and I look at the jobs, now this job is running again. Now both of them are running. If I wanted to stop this job, I can use the kill command. The kill command, my thing is for kind of killing jobs, which is just like stopping them in kind of intuitively, but actually it's really useful. Like the kill command just allows you to send any sort of Unix signal. So here, for example, instead of killing it completely, we just send a stop signal. Here I'm gonna send a stop signal, which is gonna pause the process again. And now I still have to include an identifier, because without the identifier, the cell wouldn't know whether to stop the first one or the second one. That said, it has been suspended because there was a signal sent. If I do jobs again, we can see that the second one is running and the first one has been stopped. Going back to one of the questions was, what happens when you close the cell, for example? And why sometimes people will say that you should use this no hsub command before you run jobs in a remote session. This is because if we try to send a hangup command to the first job, it's gonna, in a similar fashion as the other signals, it's gonna hang it up. And that's gonna terminate the job. And the first job isn't there anymore. Whereas we have still the second job running. However, if we try to send the signal to the second job, which will happen if we close our terminal right now, it's still running. Like nohab, what it's doing is kind of encapsulating your whatever command you're executing and ignoring wherever you get like a signal, like a hang-up signal, and just ignoring that so it can keep running. And if we send the kill signal to the second job, that one can be ignored, and that will kill the job no matter what. And we don't have any jobs anymore. Kind of completes the section on job control. Any questions so far? Anything that wasn't kind of fully clear?
What does BG do?
So BG, there are two commands. Whenever you have a command that has been backgrounded and it's stopped, you can use BG sort for background to continue that process running on the background. That's equivalent of just kind of sending it a continuous signal so it keeps running. And then there's another one which is called FG if you want to kind of recover it to the foreground and you want to reattach your standard output. Okay, good. Jobs are useful, and in general, I think the kind of knowing about signals can be really beneficial when dealing with some part of Unix. But most of the time, what you actually want to do is something along the lines of having your editor in one side and then the program in another, and maybe monitoring what the resource consumption is in our tab. We could achieve this using probably what I've seen a lot of time, which is just opening more windows. We can keep opening terminal windows. But the fact is there are kind of more convenient solution to this. And this is what a terminal multiplexer does. A terminal multiplexer, like Tmux, will let you create different workspaces that you can work in and quickly kind of, has like a huge variety of functionality. It will let you kind of rearrange the environment, and it will let you have different sessions. There's another more older command which is called screen that might be more readily available, but I think the concepts kind of extrapolate to both. We recommend Tmux, that you go and learn it, and in fact we have exercises on it. I'm gonna kind of showcase the functionality right now. So whenever I told, let me make a quick note. There are kind of 3 core concepts in Tmux that I'm gonna go through, and the main idea is that there are what is called sessions. Sessions have windows, and windows have panes. And it's gonna be kind of useful to keep this hierarchy in mind. You can pretty much equate windows to what tabs are in other editors and other, like for example, your web browser. I'm gonna go through features, mainly what can you do at the different levels. So first, when we do Tmux, that starts a session, and here right now it seems like nothing changed, but what's happening right now is we're within a cell that's different from the one we started before. So our original cell started a process that is Tmux, and that Tmux started a different process, which is the cell we're currently in. And the nice thing about this is that that Tmux process is separate from the original cell process. So here we can do things. We can do ls-a, for example, to list what is going on in here. And then we can start running our program, and it will start running in there. And we can do Control-A-D, for example, to detach. I can enable start casting. Yeah, let me move. To detach from the session. And if we do Tmux A, that's gonna reattach us to the session. So the process, we abandon a process kind of counting numbers. This is like really silly Python program that was just counting numbers. We like left it running there. And if we Tmux A, like the process is still running there. And we could close this entire terminal and open a new one. And we could still reattach because this Tmux session is still running. Again, we can, before I go any further, pretty much all, like unlike Vim, where they have like this notion of modes, Tmux will work in a more Emacsy way, which is every command in, like pretty much every command in Tmux, or pretty much every command in Tmux, you could enter it through has like a command line that we could use. But I recommend you to get familiar with the key bindings. It can be somehow unintuitive at first, but once you get used to them, exit is gonna Control-C. When you get familiar with them, you will be much faster just using the key bindings than using the commands. One note about the key bindings: all the key bindings have a form that is like you type a prefix and then some key. So, for example, to detach, we do Control-A and then D. This means you press Control-D first, you release that, and then press D to detach. On default Tmux, the prefix is Control-B, but you will find that most people will have this remap to Control-A because it's much more ergonomic to type on the keyboard. You can find more about how to do these things in one of the exercises where we link you to the basics and how to do some kind of quality of life of modifications to Tmux. Going back to the concept of sessions, we can create like a new session, just doing something like Tmux new, and we can give sessions names. So we can do like Tmux new foobar, and this is a completely different session that we have started. We can work here, we can detach from it. Tmux ls will tell us that we have 2 different sessions. The first one is named 0 because I didn't give it a name, and the second one is called foobar. And I can attach the foobar session, and I can end it. It's really nice because Having this, you can kind of work in completely different projects. For example, having 2 different TMUX sessions and have different like editor sessions, different processes running. When you are within a session, we start with the concept of windows. Here we have a single window, but we can use Control A, C for create to open a new window. And here, nothing is executing. What it's doing, TMUX has opened a new cell for us. And we can start running another one of these programs here. And to quickly jump between the tabs, we can do Control A and previous, like P for previous, and that will go us to the previous window. Control A next to go to the next window. You can also use the numbers. So if we start opening a lot of these tabs, we could use Control A1 to specifically jump to the window that is number 1. And lastly, it's pretty useful to know sometimes that you can rename them. For example, here I'm executing this Python process, but that might not be really informative, and I maybe want to have something like execution or something like that. And that will rename the name of that window so you can have this very neatly organized. This still doesn't solve the need when you want to have 2 things at the same time in your terminal, like in the same display. This is what panes are for. Right now here we have a window with a single pane. All the windows that we have opened so far have a single pane. But if we do Control A, double quotes, this will split the current display into 2 different panes. So you see like the one we open below is a different cell from the one we have above, and we can run any process that we want here. We can keep splitting this. If we do Control A %, that will split vertically. And you can kind of rearrange these tabs using a lot of different commands. One that I find is very useful when you are starting and it's kind of frustrating rearranging them. Oh, before I explain that, to move through these panes, which is something you want to be doing all the time, you just do Control A and the arrow keys, and that will let you quickly kind of navigate through the different windows and execute. Again, like I'm doing a lot of ls minus a, but I don't have. I can do htop that will explain in the debugging and profiling lecture. And we can just navigate through them. Again, like to rearrange this another slew of commands, you will go through some in the exercises. Control A space is pretty neat because it will kind of X space the current ones and let you through different layouts. Some of them are too small for my current terminal config. But that covers, I think, like most of the, oh, there's also, here, for example, this beam execution that we have started is too small for what the current TMUX pane is. So one of the things that really is much more convenient to do in TMUX, in contrast to having multiple terminal windows, is that you can zoom into this. You can ask, by doing Control A C set for zoom, it will expand the entire pane to take over all the space, and then Control A set again will go back to it. Any questions for terminal multiplexers or like TMUX concretely?
Is it running all of the same thing, like simultaneously? Like, is there any different in execution between having different windows or like different threads or multi-process? Like, is it really just doing it all the same so that you can see it?
Yeah, there isn't like it wouldn't be any different from having 2 terminal windows open in your computer. Like both of them are gonna be running. Of course, like when it gets to the CPU, this is gonna be multiplex again. Like there's like a time steering mechanism going there, but there is no different. Like TMUX is just making this much more convenient to use by giving you this kind of visual layout that you can quickly manipulate through. And one of the main advantages will come when we reach the remote machines, because you can leave one of these, we can detach from one of these TMUX sessions, close the connection, and even if we close the connection and the terminal is going to send a hang up signal, that's not going to close all the TMUX session that has been started. Any other questions? Let me disable the Keycaster. So now we're going to move into the topic of dot files and in general how to kind of configure your cell to do the things you want to do, and mainly how to do them quicker and in a more convenient way. I'm going to motivate this using aliases first. So what an alias is that by now you might be starting to do something like, oh, a lot of the time I just want to ls a directory and I want to display all the contents in a list format and in a human readable thing. And it's fine, like it's not that long of a command, but just as you start building longer and longer commands, it can become kind of bothersome having to retype them again and again. This is one of the reasons why aliases are useful. Alias is a command that will be a built-in in your cell, and what it will do is it will remap a source sequence of characters to a longer sequence. So if I do, for example, here alias ll equals ls minus lah, if I execute this command, this is going to call the alias command with this argument, and the alias is going to update the environment in my cell to be aware of this mapping. So if I now do ll, it's executing that command without me having to type the entire command. They can be really handy for very many reasons. One thing to note before I go any further is that here, alias is not anything special compared to other commands. It's just taking a single argument. And there is no space around these equals, and that's because alias takes a single argument. And if you try doing something like this, that's giving it more than one argument, and that's not gonna work, because that's not the format it expects. So other use cases that work for aliases, as I was saying, for some things it might be much more convenient. Like one of my favorites is get status. It's extremely long. I don't like typing the long of a command every so often because you end up typing a lot of the time. So GS will replace for doing the get status. You can also use them to alias things that you'd mistype often. So you can do SL equal LS. That will work. Other useful mappings are you might want to alias a command to itself, but with a default flag. So here what is going on is I'm creating an alias, which is an alias for the move command, which is mv, and I'm aliasing to the same command, but adding the -i flag. And this -i flag, if you go through the man page and look at it, it stands for interactive. And what it will do is it will prompt me before I do an override. So once I have executed this, I can do something like, oh, I want to move aliases into case. By default, move won't ask. And if case already exists, it will be, oh, that's fine. I'm going to override whatever that's there. But here is now expanded. Move has been expanded into this move -i. And is using that to ask me, oh, are you sure you want to override this? And I can say, no, I don't want to lose that file. Lastly, you can use alias move to ask for what this alias stands for. So like, it will tell you, so you can quickly make sure that what the command that you are actually executing is. One inconvenient part about, for example, having aliases is how will you go about persisting them into your current environment? Like if I were to close this terminal now, all these aliases will go away. And you don't want to be kind of retyping these commands. And more generally, if you start configuring yourself more and more, you want some way of bootstrapping all this configuration. You will find that most cell programs will use some sort of text-based configuration file. And this is what we usually call dot files, because they start with a dot for historical reasons. So for bus, in our case, which is a cell, we can look at the bus.rc. And for demonstration purposes here, I have been using sysates, which is a different cell, and I'm going to be configuring bus and starting bus. So if I create an entry here, and I say, oh, cell maps to ls, and I have modified that, and now I start bus. Bus is kind of completely unconfigured, but now if I do sl, that's unexpected. Why is
You're not in your home directory.
Oh, good. So it matters where your config file is, and your config file needs to be in your home folder. So the configuration file for bus will live in the tilde, which will expand to your home directory, and then bus.rc. And here we can create the alias. And now we start a bus session, and we do sl. Now it has been loaded, and this is telling that like it's loaded at the beginning when this bus program is started, and all this configuration is loaded. And you can not only use aliases, you can add a lot of parts of configuration. So for example, here I have a prompt which is fairly useless. Like it has just given me the name of the cell, which is bus, and like the version, which is 5.0. I don't want this to be displayed. As with many things in your cell, this is just an environment variable. So the ps1 is just what is the prompt string for your prompt. And we can actually modify this to just be greater than symbol. And now that has been modified, and we have that. But if we exit and call bus again, that was lost. However, if we add this entry and say, oh, we want ps1 to be this, and we call bus again, this has been persisted. And we can keep modifying this configuration. So maybe we want to include where the working directory that we are is in, and that's telling us the same information that we had in the other cell. And there are many options. Like cells are highly configurable. And it's not only cells that are configured through these files. There are many other programs. As we saw, for example, in the editors lecture, Beam is also configured this way. We gave you this beamrc file and told you to put it in your under home.beamrc. And this is the same concept, but just for Beam. It's just giving it a set of instructions that it should load when it's started, so you can keep a configuration that you want. And even a lot of programs will support this. For instance, my terminal emulator, which is another concept, which is the program that is running the cell in a way and displaying this into the screen in my computer, can also be configured this way. So if I modify this, I can change the size of the font. Like right now, for example, I have increased the font size a lot, so for demonstration purposes. But if I change this entry and make it, for example, 28 and write this value, you've seen that the size of the font has changed because I edited this text file that specifies how my terminal emulator should work. Any questions so far with dot files? Okay, it can be a bit daunting, kind of knowing that there is like this endless world of configurations, and how do you go about learning about what can be configured? The good news is that we have linked you to really good resources in the lecture notes, but the main idea is that a lot of people really like just configuring these tools and have uploaded their configuration files to GitHub and other different kind of repositories online. So for example, here we are on GitHub, we search for .files, and you can see that there are like thousands of like repositories of people sharing their configuration files. We have also like the class instructors have linked to our .file, so if you really want to know how any part of our setup is working, you can go through it and try to figure out. You can also feel free to ask us. If we go, for example, to this repository here, we can see that there's many files that you can configure. For example, there is one for Bash, for example, one for Git that will probably be covered in the version control lecture tomorrow. If we go, for example, to the Bash profile, which is a different form of what we saw in the Bash RC, it can be really useful because you can learn through doing just looking at the manual page, but the manual pages in a lot of the time are just kind of like a descriptive explanation of all the different options. And sometimes it's more helpful going through examples of what people have done and trying to understand why they did it and how it's helping their workflow. And we can say here that this person has done case-insensitive globbing. We covered globbing as this kind of file name expansion trick in the cell scripting on tools. And he's saying, no, I don't want this to be kind of matter whether I'm using uppercase and lowercase, and just setting this option in the cell for these things to work this way. Similarly, there is, for example, aliases. Here we can see a lot of aliases that this person is doing. For example, D for CD, because that's, or like for Dropbox, sorry, because that's just much shorter, G for Git. Same will go, for example, with bmerc. It can be actually very informative going through this and try to extract useful information. We do not recommend just kind of getting one huge blob of this and copying this into your config files, because maybe things are prettier, but you might not really understand what is going on. Lastly, one thing I want to mention about .files is that people not only try to push these files into GitHub just so other people can read it, that's one reason. They also make really sure they can kind of reproduce their setup. And to do that, they use a slew of different tools. Oops, went a little too far. There, here. So Genius Stow is, for example, one of them. And the trick that they are doing is they are kind of putting all their .files in a folder, and they are kind of faking to the system using a tool called Symlinks that they are actually where they are not. I'm gonna draw really quick what I mean by that. So a common folder structure might look like you have your home folder, and in this home folder, you might have your Bash RC that contains your Bash configuration. You might have your bmerc. And it would be really great if you could keep this under version control. But the thing is, you might not want to have a Git repository, which will be covered tomorrow, in your home folder. So what people usually do is they create a .files repository, and then they have entries here for their Bash RC and then bmerc. And this is where the actually, like the files are. What they're doing is they're just telling the OS to forward, kind of like whenever anyone wants to read this file or write to this file, just forward this to this other file. This is a concept called Symlinks, and it's useful in this scenario, but in general, it's a really useful tool in Unix that we kind of haven't covered so far in the lectures, but you might be, that you should be familiar with. And in general, the syntax will be ln minus s for specifying a symbolic link, and then you will put the kind of the path to the file that you want to create, and then the symlink that you want to create. And all these kind of fancy tools that we're seeing here listed, they all amount to doing some sort of this trick. so that you can have all your dot files neat and tidy into a folder, and then they can be version controlled, and then they can be symlinked, so the rest of the programs can find them in their default locations. Any questions regarding dot files?
To use symlinks, do you need to have the dot files in the home folder and then also dot files in the version control folder?
So what you will have is pretty much every program, for example, Bash, will always look for home basrc. That's like where the program is going to look for. What you do when you do a symlink is you place like your home.basrc is just a file that is kind of a special file in Unix that says, oh, whenever you want to read this file, go to this other file. And there's no content, like there is no, like your aliases are not part of that file. That file is just kind of like a pointer saying, you should go that other way. And by doing that, you can have your other file in that other folder. If in version controlling is not useful, think about what if you want to have them in your Dropbox folder. So like they're synced to the cloud, for example. That's kind of another use case where like symlinks could be really useful.
So you don't need the folder, or sorry, that file in the home directory, right? Because you can just use the symlink.
Yep.
It'll always just point somewhere else.
As long you have a way for the kind of the default path to resolve wherever you have it, yeah. Last thing I want to cover in the lecture. Oh, sorry. Any other questions about dot files? Last thing I want to cover in the lecture is working with remote machines, which is a thing that you will run earlier, so like sooner or later, and there's a few things that will make your life much easier when dealing with remote machines. If you know about them. And right now, maybe because you're using the Athena cluster, but like later on in your programming career, it's pretty sure that there's a fairly ubiquitous concept of having your kind of local working environment and then having some production server that is actually running the code. So it's really good to get familiar about how to working with remote machines. So the main command for working with remote machines is SSH. Is SSH. SSH is just like a secure shell. It's just gonna take the responsibility for kind of reaching wherever we tell it to go, and trying to kind of open a session there. So here the syntax is JJGO is the user that I want to use in the remote machine, and this is because the user is different from the one I have in my local machine, which will be the case a lot of the time. Then the is telling the terminal that this separates what the user is from what the address is. Here I'm using an IP address because what I'm actually doing is I have a virtual machine in my computer that is the one that is remote right now. And I'm gonna be SSHing into it. This is the URL that I'm using, sorry, the IP that I'm using. But you might also see things like, oh, I want to SSH GGU foobar mit.edu. That's probably something more common if you're using some remote server that has a DNS name. So going back to our regular command, we try to SSH, ask us for a password, really common thing, and now we're there. We are still in our same terminal emulator, but right now SSH is kind of forwarding the entire virtual display to display what the remote shell is displaying. And we can execute commands here, and we'll see the remote files. A couple of handy things to know about SSH that were briefly covered in the data wrangling lecture is that SSH is not only good for just opening connections, it will also let you just execute commands remotely. So for example, if I do that, it's gonna ask me what is my password again, and it's executing this command then coming back to my terminal and piping the output of what that command was in the remote machine through the standard output in my current cell. And I could have this in, I could have this in a pipe, and this will work, and we'll just grab all this output and then have a local pipe where I can keep working. So far, it has been kind of inconvenient having to type our passwords. There's one really good trick for this is we can use a thing called SSH keys. SSH keys just uses public key encryption to create like a pair of SSH keys, a public key and a private key. And then you can give the server the public part of the key so that you copy the public key, and then whenever you try to authenticate, instead of using your password, it's gonna use the private key to prove to the server that you're actually who you say you are. We can quickly showcase how will you go about doing this. Right now I don't have any SSH keys, so I'm gonna create a couple of them. First thing is just gonna ask me where I want this key to live. Surprisingly, it's doing this. This is my home folder, and then it's using this .ssh path, which refers back to the same concept that we covered earlier about having dot files. Like .ssh is a folder that contains a lot of the configuration files for how you want SSH to behave. So it will ask us a passphrase. The passphrase is to encrypt the private part of the key, because if someone gets your private key, if you don't have a password-protected private key, if they get that key, they can use that key to impersonate you in any server. Whereas if you add a passphrase, they will have to know what the passphrase is to actually use the key. And as created a keeper, we can check that these two files are now under SSH, and we can see, too small for this. And we have these two files. We have the 25519 and the public key. And if we cut through the output, that key is actually, it's not like any fancy binary file. It's a it's just a text file that has the contents of the public key and some alias name for it, so we can like know what this public key is. And the way we can tell the server that like we're authorized to SSH there is just actually copying this file, like copying this string into a file that is SSH authorized host. So if we hear what I'm doing is I'm cutting the output of this file, which is just this line of text that we want to copy, and I'm piping that into SSH, and then remotely I'm asking T to dump the contents of the standard input into SSH those authorized keys. And if we do that, obviously it's going to ask us for a password. And it was copied, and now we can check that if we try to SSH again, it's going to first ask us for passphrase, but you can arrange that so that's saved in the session. And we didn't actually have to type the key for the server. And I can kind of show that again. Why is not saving? More things that are useful. Oh, we can do, if that command seemed like a little bit janky, you can actually use, there's a command that is built for this, so you don't have to kind of craft this SSHT command that is just called SSH copy AD. And we can do the same, and it's gonna copy the key. And now if we try to SSH, we can SSH without actually typing any key at all, or any password. More things, we will probably want to copy files. You cannot use CP, but you can use SCP for kind of like SSH copy. And here we can specify that we want to copy this local file called notes. And the syntax is kind of similar. We want to copy it to this remote. And then we have a semicolon to separate what the path is going to be, and then we have, oh, we want to copy this as notes, but we could also copy this as foobar. And if we do that, it has been executed, and it's telling us that all the contents have been copied there. If you're going to be copying a lot of files, there is a bare command that you should be using that is called rsync. For example, here, just specifying these 3 flags, I'm telling rsync to kind of preserve all the permissions whenever possible to try to check if the file has already been copied. For example, SCP will try to copy files that are already there. This will happen, for example, if you're trying to copy and the connection interrupts in the middle of it. SCP will start from the very beginning trying to copy every file, whereas rsync will continue from where it started. And here, we ask it to copy the entire folder, and it's just really quickly copied the entire folder. One of the other things to know about SSH is that the equivalent of the dot file for SSH is the SSH config. So if we edit the SSH config to be, let's see. I have to copy, right? Okay. It's vim config. If I edit the .ssh config to look something like this, instead of having to every time type SSH, JJGo, like having this really long string so I can like refer to this specific remote I want to refer with the specific username, I can have something here, like say, oh, this is the username, this is the host name that this host is referring to, and you should use this identity file. And if I copy this is right now in my local folder, I can copy this into SSH. Now, instead of having to do this really long command, I can just say, oh, I just want to SSH into the host called VM. And by doing that, it's grabbing all that configuration from the SSH config and applying it here. And this solution is much better than something like creating an alias for SSH, because other programs like SCP and rsync also know about the dot files for SSH and will use them whenever they are there. Last thing I want to cover about remote machines is that here, for example, we also have tmux, and we can, like I was saying before, we can start editing some file and Control B, and we can start running some job. Of course. And why? Oh, and for example, something like htop, and this is running here. We can detach from it, close the connection, and then SSH back. And then if you do tmux A, everything is as you left it. Like nothing has really changed. And like if you have things executing there in the background, they will keep executing. I think that pretty much ends all I have to say for this tool. Any questions related to remote machines?
How do you deal with having a tmux on the local terminal and a tmux on the SSH terminal?
That's a really good question. So what I do for that, and I can repeat the question. Oh, yeah, sorry. So the question is, how do you deal with trying to use tmux in your local machine and also trying to use tmux into the remote machine? There are a couple of tricks for dealing with that. The first one is changing the prefix. So what I do, for example, is in my local machine, the prefix I have changed from Control B to Control A. And then in the remote machines, it's still Control B. So I can kind of swap between, like if I want to do things to the local tmux, I will do Control A. And if I want to do things to the remote tmux, I would do Control B. And another good another thing that I do is you can have separate configs. So I can do something like this, and then probably that. Because I don't have my SSH config. Yeah. But if you, I can just SSH VM. here, what you see, the difference between these two bars, for example, is because the Tmax config is different. As you will see in the exercises, the Tmax configuration is in the .tmax.conf, and no, it's not in CD yet. And tmax.conf, and here you can do a lot of things like changing the color depending on the host you are, so you can get like quick visual feedback about where you are, or like if you have a nested session. Also, Tmax will, if you're in the same host and you try to Tmax within a Tmax session, it will kind of prevent you from doing it, so you don't run into issues. Any other questions related to kind of all the topics we have covered?
Another answer to that question is also, if you type the prefix twice, it sends it once to the underlying shell. So if the local binding is Control A and the remote binding is Control A, you could type Control A, and then D, for example, detach from the remote session.
Okay, I think that ends the class for today. There's a bunch of exercises related to all these main topics. We're going to be holding office hours today too, so feel free to come and ask us any questions.